Okay, what we're going to look at is what we need to do to find and classify the stationary points of the two functions that are given. So to find, basically when we have to find, it means we are looking at our x and y intercepts and also our turning points. And then because we are classifying the stationary point, what it means by classify is we are looking at the nature, okay, whether it has a minimum, a maximum, or a point of inflection. Okay, so we started off by looking at the derivative function, and we've derived the function. Obviously, that is the gradient function, so equating it to 0 because it's a stationary point, we are expecting a horizontal line which has a gradient of 0. And if we equate the gradient of 0, we find our x coordinate. So that means the point at which we get the stationary point. To find the y coordinate, we simply substitute that into the original equation over there, and we get our turning point coordinate of 3 and 27. So what we've done is we have found our turning point, and we found the coordinates of the turning point. Now that we've found the turning point, let's find the nature of these turning points. And to do that, we use the table method. So we use the table method, and what the table method is basically we write whatever we have. So we take our x values and we take our y dash, which is the derivative function. Now we know that at x is equal to 3, our gradient is equal to 0. Okay, now to find out what the nature is before 3 and after 3, let's take one value on either side of 3. So we'll take 1 less than 3, which is 2, and we'll take 1 more than 3, which is 4. And all we do to find out what we get over here is substitute these x values into the gradient function. So the gradient function, so basically at x equals, sorry, not 3, x equals 3, y was 0. When x is equal to 2, sorry, not y dash was 12 take away 4 into 2, which means 12 take away 8, and that gives us 4. So when x is equal to 2, our y dash was 4. And when x is equal to 4, our gradient function, that gives us 12 take away 4 multiplied by 4, which is 12 take away 16, and that gives us -4. And that is -4. So if we have a look at the stationary point, basically we have a horizontal line. Before the stationary point, because this is a positive gradient, that means it looks like that. Positive gradient line looks like that. A negative gradient looks like that. So what we can say is that the shape, again, the shape is that, which means that it has a maximum turning point. Okay, for the next example, we need to sketch the function of y equals x plus 1 into x plus 2 into x minus 1 using calculus methods. So all we need to do is we need to sketch the function, and we have to use calculus methods. Now, as we mentioned before, when we use calculus methods and we have to sketch, these are the things that we need to take note of. We need to find our x and y intercepts. We need to find where the turning point is and what the nature of that is, okay, including what the roots are. And we also need to state whether it has a minimum or maximum turning point. So or point of inflection. Okay, so let's start off. The simplest way to start is to find our x and y intercepts. Now, as with everything, to find our x-intercept, we let y equal 0. So what we end up with is 0 is equal to x plus 1 into x plus 2 into x minus 1. What that means is that either x plus 1 equals 0, so x is equal to negative 1, or x plus 2 equals 0, so x equals negative 2, or x minus 1 equals 0, so x equals 1. So the coordinates of our x-intercepts are negative 1, 0, negative 2, 0, and 1, 0. Likewise, to find our y-intercept, we let x is equal to 0. So what we end up with is y is equal to 0 plus 1 times 0 plus 2 times 0 take away 1, and that gives us 1 times 2 times negative 1, and that is negative 2. So therefore the coordinates of our y-intercept is 0, negative 2. Okay, so I'm just going to highlight these. Okay, so now that we've found our x and y intercepts, the next thing we want to do is to find our turning point and the nature of the turning point. So that's the second thing. So let's find our turning points, our stationary point, and the nature. Okay, let's write down over here that this is the first step to find your intercepts. Okay. Now, so our equation is y equals x plus 1 times x plus 2 into x minus 1. Okay. Now, to find the derivative function, let's expand that first. So if we expand the first couple of brackets, we will get x squared plus 3x plus 2. And that's expanded into x take away 1, which gives us x cubed plus 2x squared minus 2x minus 2. Sorry, minus x minus 2. Okay, now to find the derivative function, all we do is we differentiate that, and that gives us 3x squared plus 4x take away 1. Now, this is giving us the gradient function. So, as we did before, to find out what the coordinates of these points are, okay, so basically finding the roots, what the coordinates are, we equate that to 0, so that becomes 0 is equal to 3x squared plus 4x minus 1. You can factorize that first, or you can use your quadratic formula. Okay, now obviously a is equal to 3, b is equal to 4, and c is equal to negative 1. So therefore, your x is equal to minus b plus or minus b squared minus 4ac over 2a. And if we sub all of that, that's negative 4 plus or minus square root of 4 squared minus 4 times 3 times negative 1 over 2 times 3. I'll just put a times over there. And what we end up getting is, okay, so if I calculate this on the calculator, I get, so the two values that you get is negative 1.549 and 0.215. Now, let's see what the nature is of this curve. So that's the third part, okay? And again, we can use the table method. Alright, so if I use the table method, x, that's y dash. So all we're doing is we're subbing into, actually, let's get rid of that, just make this a bigger table so that we have enough space. Okay. So all we're doing is we'll just sub into the derivative formula. Now our two values are negative 1.549 and 0.215. So let's write that down, negative 1.549 and then 0.215. So what we can do is we can take values on either side of both those two values. So what I can do is maybe I can take negative 2 over here. So we make sure that we do take the 2 points on either side of both the turning points. And we can say take negative 1 over here. And on the other side of 0.215, we can take maybe 0, and maybe we can take 1. So now we have 1, 2, 3, 4, 5, 6 points. All we need to do to find this value, obviously this is equal to 0 and that is equal to 0. So let's substitute each of these values, negative 2, into the y dash formula. So when x is equal to negative 2, y dash would be equal to, pretty sure it's 3x squared, yep. 3 into negative 2 squared plus 4 into negative 2, take away 1. And we do that for each of those values. Basically, by substituting all of these values, that's what you get. Let's fill up our table. So when x is negative 2, our y dash was 3. That is 0. Negative 1 gives us negative 2. 0 gives us negative 1. And 1 gives us 6. So now the shape, if you have a look, this is positive gradient, so looking like that. This is 0. That's negative gradient, looking like that. Another negative gradient, so that means it'll keep continuing. This is a 0. I'm just going to draw that so that that's a 0, and then that becomes positive. So basically you can say that the shape is looking like that, which kind of matches, if you have a look, your function was, the function that we had was x plus 1 into x plus 2 into x minus 1, and this is a positive cubic function. So you should be expecting a shape looking like that anyway. And this kind of reconfirms that, yes, that's what the shape of our function is. And then one last thing left is to sketch this. So we need to, so the last thing left is to sketch. And to sketch this, we need to remember that we need to find the coordinates of the turning points. And to do that, all we do is we sub x equals 0, negative 1.549 into y to get your y value, and we also sub x equals 215 into your y function, which gives us our 2 turning points. And then all you do is you sketch using all that information of y is equal to x plus 1, x plus 2, and x minus 1.